All right, let's do this problem called reverse bits. Let's have a read. Reverse bits of a given 32 bits unsigned integer. Okay. Note. Noted in some languages such as Java, there is no unsigned integer case. In this case, both input and output will be given as signed integer type. This should not affect your implementation as the integer's internal binary representation is the same, whether it is signed or unsigned. Okay. In Java, the compiler represents the signed integers using 2's complement notation. Therefore, in example 2 above, the input represents the signed integer -3 and the output represents the signed integer. Okay, I didn't fully get it, but yeah, whatever. Right now, this is the input. We are given some large value, 32-bit, and what's the actual thing? Okay, reverse bits. So now it says the input binary string. You convert it into 32 bits and then you reverse it, which is this 00111010 something like that. Uh, okay, makes sense. Now how do we do it? This is the input, and so how is the input given? I'm not fully clear on how the input is actually given. Like, is the because is the input given like this or what? Like, okay, let me do just one sec. Uh, so I do this out dot. I just want to see whether like this is the test case, but this is not n, right? N is given as some integer, right? Just want to confirm that. So okay. In the first case, this is what they're done a very good case of representing the things that is given. Very nice. Um, but yeah, essentially this is what you were given as n, and that's the binary representation of it. So what we're looking at is the binary representation. Okay, fair enough. So whatever binary representation is given to us, now we have to work on those bits and reverse them. Sorry about that. Okay. So how can we do that? One of the ways is maybe we take a 32-bit, we take a 32-bit array and save the bits there, and then reverse it, and then form a number based on that. Let's try that. Okay. So I mean that's the basic case. So and it's not really taking too much space. So I do um, let's do int, but okay, we can optimize and take like a char array or a boolean array or whatever. But let's start with the char array and an int array. So int array, uh, call it bits equals to new int of size 32. And now let's save the bits, right? So how do we save the bits? Could I actually just create the could I actually just create the uh, result directly without even saving? I'm wondering. Let's do this one first. So let's take a simple example, right? A simple example would be, I think the answer is no to that, right? Because you have to take all 32 bits, right? So you have to consider all 32 bits. And obviously you initialize them to 0, which is fair. And then you want to get each and every bit. So percentile 2 or right shift y1 we can keep doing. So I do Okay, now I can do uh, bits of I equals to, how do I get the last bit? It has to be either 0 or 1, right? Yeah. So just do percentile 2. So I do bits of I equals to n percentile 2, and then I do n equals to n divided by 2, sort of, but I just want to do like a right shift instead of this. So okay, so then you can do bits of I equals to n and 1, and you can do n equals to n right shifted by 1. That makes sense? Fair enough. And so now my array would be created, and I have to convert it into a number. And so to do that, I could, yeah, I feel like I don't necessarily need to save it into the array, and maybe I'll improve upon that. But initially, now what I wanna do is I want to create a number out of this. So I get the lastmost array, lastmost bit, and I want to add it to something. The way to add that to something would be um, you left shift it and you or it. Okay, so let's try that. So I do int, let's call it result equals to 0, and so I do equals to n and 1, and then I can do n equals to n shifted by 1, and in result I have to add this bit. So result equals to result left shifted by 1 first of all, and then you want to be able to do a or with this bit, right? Make sense? Think so. So this is the thing, and then you want to be able to return result. Let's see if it works, and we don't need this bits array if it actually works. Works for case 1, works for case 2, then submit. And it seems to work. Okay, so it was a simple problem. You read the lastmost bit, add it to the you read a bit from the right, add it to the results bit, and I keep adding it to the result at the uh, yeah. So you read the rightmost bit, that will become your leftmost bit, right? And you keep doing that. All right.